Welcome everyone. In the last lecture, we discussed the simplification of speed time curve using the trapezoidal and quadrilateral methods. In this lecture, we will try to calculate or derive an expression for tractive force available on the electro locomotives. But before that, we should discuss some basic terminologies which will be used in later discussions, which are the dead weight of the train or the locomotive. The dead weight of the locomotive means the gross weight of the locomotive at rest. Gross weight means the weight of the loco engine plus the weight of the wheels plus the weight of the auxiliary items present on the locomotive. This weight is generally measured, represented in tons, but during the calculation we will be converting this ton into kilograms. Remember it by multiplying it with the 1000 factor. Next is the acceleration weight, which is generally mentioned with WE. The weight of the locomotive generally changes when it is accelerating due to the presence of inertial factor, and it is represented by WE. So WE, it is the weight due to the rotational inertia of the locomotive at angular acceleration, and it is generally the 110% of the dead weight. 110% of dead weight. In another way, we can represent it as WE to be equal to 1.1 of W. As we need to calculate the expression for tractive force, so we will be required to use the weight of the locomotive, but instead of using the dead weight of the locomotive, we will be using the effective weight or the accelerating weight of the locomotive. But before going on to the calculation, we should see the mechanics behind the locomotive. Here the picture shows, let me change the marker color. The picture shows the mechanics of a wheel drive of a locomotive. Here this is the wheel of the locomotive, which is attached to the shaft. That is, the wheel is getting its mechanical energy from the shaft, and further the shaft is attached to the gear wheel. This is gear wheel, which is responsible to deliver mechanical energy to the shaft, and shaft further delivers mechanical energy to the wheel. Further, this gear wheel is getting its mechanical energy from the pinion gear. This is pinion gear, where this pinion gear is further getting the mechanical energy from the traction motor. That is, this shaft will now be attached to the rotor part of the traction motor. Let us see this in a more diagrammatical way. This diagram particularly shows that there is a traction motor which is connected to the pinion. This is the pinion gear. Further, this pinion gear is connected to the gear wheel of the drive, and this gear wheel is transferring the mechanical energy to the wheel of the locomotive via the shaft. We needed to know this mechanism to calculate the tractive effort or tractive force. Let us go ahead. Here, this picture shows the simplified diagram of the wheel gear mechanism, where this is the pinion gear attached to the traction motor. It means this, whatever the torque that the traction motor is producing will be directly transferred to the pinion gear. Now the energy available at the pinion gear will be transferred to the gear wheel via the gearing mechanism, and the energy available at the gear wheel will be transferred to the wheel with some losses. Say a force is produced at the tangential to this pinion gear, which is, let me represent it with Fp. Now this Fp will be translated by this gear wheel and will be available at the wheel, and let me say the force now available at the wheel is Fw, which is our tractive force, and we need to find an expression for this Fw. Let us do some markings. Let us assume that capital D is the diameter of the wheel and small d dash is the diameter of the gear wheel, and small d is the diameter of the pinion wheel. Let us start with the derivation process. Let me say TP is the torque produced on the pinion wheel, and which will be equal to force into distance, where force on the pinion wheel is Fp, we have already mentioned Fp, and the distance would be the half of the diameter of the pinion wheel, so it will be d by 2. So the torque produced on the pinion wheel will be equal to Fp times d by 2. As this Fp is acting tangential to this pinion wheel and the gear wheel, so this Fp will be acting also on the gear wheel also. So the torque produced on the gear wheel will be Tg. This will be equal to Fp times the half of the diameter of gear wheel, which is d dash by 2, which can be written as Fp times d dash whole divided by 2. Similarly, the torque available on the wheel would be Tw, and this will be equal to Fw, the force available on the wheel, times half of the diameter of the wheel. Half of the diameter of the wheel means d divided by 2. This is the torque available on the wheel now. Let us say eta is the efficiency with which the torque on the gear wheel is transferred to the wheel. So eta will be defined as Tw divided by Tg, where Tw is Fw times d by 2. So it will be Fw d divided by 2. This whole will be divided by Fp times d dash by 2. Fp times d dash divided by 2. After solving, I can write it as Fw times d divided by Fp times d dash. We needed an expression for Fw, so we will take this Fw to the left hand side, and will try to adjust all other factors in the right hand side. So Fw will be equal to eta times Fp times d dash divided by d. We have an expression for Fp over here, that Tp is equal to Fp times d by 2. From here Fp will be equal to 2 Tp by d. I should write it here. Fp will be equal to Tp times 2 divided by d. We can substitute this value of Fp into this equation. We will get eta times 2 Tp divided by d into d dash by capital D. Now this expression can be shuffled and rewritten as 2 Tp times eta by capital D times d dash by small d, where d dash is the diameter of the gear wheel and d is the diameter of the pinion wheel. So these can be substituted by the gear ratio. This will be equal to 2 times Tp times eta by d times beta, where beta is the gear ratio and it is equal to d dash by d. So this is the required expression for the tractive force available on the wheels, and it is dependent on the torque produced by the traction motor, which is Tp times efficiency of the transmission, mechanical transmission, divided by the diameter of the wheel. Larger the diameter, lower will be the tractive force times the gear ratio. Thank you very much for this lecture, for attending this lecture. In the next lecture, we will try to find out the further expressions for FW, that is the tractive force.